They're the only part of your car that touches the road. They endure heat, rain, gravel, and thousands of pounds of pressure, all while keeping you safe at 70 miles per hour. But have you ever wondered how a car tire is actually made? It's not just rubber and air. It's a sophisticated blend of chemistry, engineering, and precision machinery. In this video, we're going deep inside the factories where millions of tires are born every year. You'll see how rubber meets steel, heat, and science, until it becomes the round, black marvel rolling beneath your feet. Let's start with the basics. Natural rubber. Harvested from rubber trees in Southeast Asia, natural rubber provides the elasticity and flexibility that allows a tire to deform under pressure, then snap back into shape. It's essential for absorbing bumps, smoothing out the ride, and handling the constant flexing that happens as the tire rolls. Made from petroleum byproducts, synthetic rubbers like styrene butadiene rubber and butadiene rubber add durability, resistance to wear, and temperature stability. These rubbers help tires perform under extreme heat, cold, and heavy loads, conditions natural rubber alone couldn't handle. Carbon black. Ever wonder why tires are black? That's carbon black, a fine black powder made from burning hydrocarbons in low oxygen conditions. It's added to the rubber to make it stronger, tougher, and UV resistant, dramatically improving tire lifespan. And fabric tires need to be flexible, but they also need to hold their shape. That's where steel wires and textile fabrics come in. Steel cords give structure and puncture resistance, especially in the tread area. Textile plies, usually made from polyester or nylon, provide shape and reinforcement for the sidewalls and body. Chemical additives. A variety of chemical agents are blended in for fine-tuning. These include sulfur, which makes rubber molecules cross-link during vulcanization, antioxidants and anti-ozonants, which protect rubber from cracking, processing oils, which improve flexibility and workability. Once all the raw materials are ready, rubbers, carbon black, steel, fabric, and chemicals, it's time to start crafting the actual rubber compound that will become the body of the tire. And it all begins in a machine that looks like a giant steel blender on steroids, the Banbury mixer. Temperatures inside can reach over 150 degrees Celsius, 300 degrees Fahrenheit. At this stage, timing is everything. If the mix runs too hot or too long, the rubber can burn or lose its elasticity. Too cold or too short, and the ingredients won't bond properly. So operators monitor every variable: temperature, torque, pressure, and time, with pinpoint precision. Once the batch is complete, the hot rubber is discharged in thick slabs called strips or cakes. These are then passed through two roll mills, huge horizontal rollers that flatten the compound into wide sheets with uniform thickness. Different formulations are prepared depending on the final function. Some compounds are soft and sticky, for tread grip. Others are dense and airtight, for the inner liner. Some are flexible but strong, for sidewalls and shoulders. Each type of rubber is carefully tagged, stacked, and stored. First up, textile reinforcement. Thin cords made from polyester, nylon, or rayon are sandwiched between rubber sheets in a process called calendering. These layers become the body plies of the tire, adding shape, flexibility, and impact resistance. Then comes the steel. High-tensile steel wires are braided together into wide belts. These belts are coated in brass for better bonding with rubber, then cut at precise angles to control how the tire flexes and grips the road. Steel belts resist punctures, reduce tread deformation, and help maintain stability at high speeds. At the very base, thick steel bead wires are wrapped into loops. These beads are what anchor the tire to the wheel rim and keep it from popping off under pressure. Together, the fabric and steel form an internal skeleton, a kind of reinforced frame that allows tires to be soft on the outside, but unyielding at their core. With all the components ready, rubber sheets, steel belts, textile plies, and bead wires, it's time to assemble the tire. This step is called green tire building, and it's where everything comes together, just not quite finished yet. The process happens on a rotating drum. Layer by layer, the tire is built from the inside out. It starts with the inner liner, a thin, airtight rubber sheet that holds air pressure. Then come the body plies, the flexible fabric layers that give the tire its shape. After that, steel bead wires are added on both edges to grip the rim. Next, sidewalls are applied, forming the tire's outer edge, followed by steel belts laid flat across the top to reinforce the tread area. Finally, a thick rubber layer, the tread, is placed on top. This is what actually touches the road. Once assembled, the uncured tire, called a green tire, is pressed, stitched, and shaped. It looks like a real tire, but it's still soft and unusable. To become roadworthy, it needs one more thing: heat. The green tire may look finished, but it's still soft, unstable, and unusable. To become a real tire, it needs to go through one final transformation: vulcanization. In this process, the green tire is placed inside a large mold, shaped like the final product. The mold is lined with engraved patterns, which will form the tread and sidewall details. Then, a rubber bladder is inserted into the center of the tire and filled with hot steam or gas. As pressure builds up to several hundred psi, it forces the tire outward against the mold walls. At the same time, the entire mold is heated to around 107 degrees, 340 degrees Fahrenheit. This activates a chemical process where sulfur cross-links the rubber molecules, making the material harder, more elastic, and permanently bonded. Within about 10 to 15 minutes, the tire emerges fully formed, with tread grooves, branding, and structural strength all locked in. Vulcanization is what makes the tire durable, springy, and able to withstand everything from highway speeds to potholes. Without it, a tire is just a pile of soft layers. Now, it's finally ready for inspection. Before any tire leaves the factory, it must pass a series of strict quality inspections, because safety depends on it. First, trained technicians check each tire by hand, feeling for bumps, bubbles, or defects in the tread and sidewall. Then, high-tech machines step in. X-rays scan for internal flaws. Laser systems check balance, roundness, and uniform thickness. Some tires are randomly selected for destructive testing, inflated until they burst, spun at high speeds, or exposed to extreme temperatures. These tests simulate real-world abuse: highways, heat waves, emergency braking. Only tires that meet every safety and performance standard, inside and out, are approved for use. The rest, rejected and recycled. Because in the world of auto safety, there's no such thing as close enough. Every tire must be perfect. From raw rubber and steel to heat, pressure, and precision, every tire is a quiet masterpiece of engineering. It's easy to take them for granted, but without them, your car wouldn't grip the road, take a corner, or keep you safe in the rain. Next time you drive, remember, there's a lot more beneath your wheels than just black rubber. There's science, craftsmanship, and thousands of decisions that all lead to one goal: keeping you moving safely. If you enjoyed this behind-the-scenes look at how auto tires are made, don't forget to subscribe to our channel for more fascinating breakdowns of the things we use every day. Hit the bell so you never miss a new episode. Like this video if you learned something new, and let us know in the comments, what should we explore next? Thanks for watching. See you in the next one.